In this video, I am going to demonstrate how to use row operations that we learned in the unit on linear algebra in order to clear a column of numbers to go from an initial table to our second table. So let's just say that this is our initial table that we have here that we've set up from our linear programming problem. And we realize that this table is not a solution to our linear programming problem because of the fact that we have negative numbers in the bottom row. If you have negative numbers in the bottom row, then this table does not represent your solution. So what we have to do then is we have to, I meant to do that. What we have to do now is find our pivot, clear the pivot column to create a new table. So the way that we do that is we go to the bottom row and we look for the most negative number. So the most negative number is the -3. That means that the X column is our pivot column. Then what we do is we need to find the pivot number in the pivot column. So the pivot number must be positive. So the 2 is positive and the 1 is positive. So which one do we choose? This is where we look at the ratios. So I'm going to take the ratio of this number divided by that number, 3/2, which is 1.5. And I'm going to take the ratio of the 2 divided by 1, which is 2. We're looking for the smallest ratio. Smallest ratio is 1.5. So the number in the pivot column in that row is our pivot. So it looks like 2 is going to be our pivot. Once we determined what the pivot is, let's try green. We now want to clear that column. And so we learned in linear algebra that means that we need to get zeros in that column. Now, the one difference between what we're doing now and what we did in linear algebra is the first thing that we would have done in linear algebra if we were doing Gauss-Jordan elimination is we would have changed our pivot 2 into a 1. So we do not need to do that. We're going to keep the 2 as a 2. And so that means that we just have to think about the row operations a little bit differently. So let me get rid of this. And let's look at what our row operations are going to be. So I'm going to rewrite the first row because that's my pivot row. And now what we want to do is we want to get rid of the 1 underneath the 2. That would be this number. We want to change that into a 0. So the way that we can do that is we always start with the changing row. And so if I take 2 times row 2 minus row 1 and then replace row 2, that would give me a 0 there. So I'm taking 2 times row 2, so 2 times the 0, 2 times the 1 would be a 2, minus row 1, 2. 2 minus 2 is 0. Going to the Y column, 2 times 2 is 4, minus 3 is 1. Next column, 2 times 0 is 0, minus 1 is minus 1. The S column, 2 times 1 is 2, minus 0 is 2. The P column, that's easy. 2 times 0 is 0, minus 0 is 0. And then the constant column, 2 times 2 is 4, minus 3 is 1. Now we need to get rid of the -3. We need to turn that into a 0. So to do that, I want to look for a multiple of my pivot and that -3. Well, multiple of 2 and 3 is 6. So it looks like if I was to take 2 times row 3, that would give me a -6, plus 3 times row 1. And that's going to replace row 3. Let's just check that. 2 times row 3. 2 times -3 would be a -6. Plus 3 times 2 would be 6. 6 and a -6 is 0. Going to the next column. 2 times a -1 is a -2. Plus 3 times 3 is 9. 9 and a -2 is 7. On to the R column. 2 times 0 is 0. Plus 3 times 1 is 3. To the S column. This one is easy. We have all zeros. So 2 times 0 plus 3 times 0 is 0. The P column. 2 times 1 is 2. Plus 3 times 0 is 0. 0 plus 2 is 2. And finally, 2 times 5 is 10. Plus 3 times 3 is 9. 10 plus 9 is 19. The only other thing to do then is to change our outgoing and incoming active variable. So R is the outgoing, X is the incoming, so I put X here, S stays, and P stays as it is. Now, we are actually done with this problem because all of the numbers in the bottom row are now positive numbers or 0. Positive numbers or 0. And so the only thing left to do would be to determine the solution. So we start with the active variables. X is equal to, we take the constant, and then this was the X column, the Y column, and then the, I believe it was RS. Yep, R and S. RSP. So X is equal to 3 divided by 2. S is an active variable. That would be 1 divided by 2. P, that's going to be our solution, is 19 divided by 2. Everything else will then be a 0. So Y is 0. And let's see, R is 0. So that means that our optimal solution is P equals 19 halves, and it occurs at the point 3 halves, 0. All right, so once again, the main focus of this video was to explain exactly how we do these row operations. So hopefully this makes some sense. I'm trying to make as many videos as I have time to make because I know this is a complicated subject. So your feedback to let me know that these are helpful will just inspire me to make some more. All right, hope you enjoyed it.